Hello students, today we'll be discussing about the solubility of gases in liquids. We know that gas dissolved in liquid also forms a solution. Here you find that solution is made up of two different components. First one is the solute and the other one the solvent. When it combines together, it forms the solution. In case of gas dissolved in liquid, gas becomes the solute and the solvent is the liquid. And that results in the solution, which is a gaseous solution. Now, what are the factors that depend upon the solubility of gas in liquid? First of all, the nature of the gas and the solvent decides whether it forms a solution or not. The other factor is temperature. We find that the gases which are easily liquefiable are more soluble in the solvent, and dissolution of a solute in solvent is an exothermic reaction. That means with increase in temperature, the amount of gas that gets dissolved in the liquid decreases. The factors that affect the solubility of gas in liquid are: first one, nature of gas and solvent. Second one, it is temperature. When we talk of nature of gas and the solvent, gases which can be easily liquefiable are more soluble in common solvents. For example, carbon dioxide is more soluble in water than oxygen or hydrogen. Whereas gases which react with the solvent possesses high solubility. Likewise, hydrochloric acid or hydrogen chloride and ammonia dissolves better in water. Oxygen, nitrogen, carbon dioxide are much more soluble in ethanol compared to that of water. Taking the next factor, temperature. Solubility of most of the gases in liquids decreases with increase in temperature. The reason is dissolution of a gas in a liquid is an exothermic reaction. That is, when temperature increases, according to Le Chatelier's principle, the system itself will try to reduce the temperature. So, it moves in the direction of endothermic reaction. That means dissolution never happens, or solubility of gases decreases with increase in temperature. When we compare the different gases, you find that solubility of oxygen and nitrogen at high temperature is lesser compared to other gases. Now we shall discuss the effect of pressure on solubility of a gas in detail. In the picture, you can find two vessels provided with a piston. First case, the piston is relatively at a higher position compared to the second one. So what can you say about the volume of the gas occupied? Here in first case the volume is much higher. That means the number of molecules per unit volume available is lesser. So collisions are lesser. So there is no direct contact between the surface of the water, and that results in less solubility. But when we are lowering the piston, that is when we increase the pressure, the number of molecules per unit volume over the liquid increases, which increases the number of collisions, and so that results in more solubility of the gas in the liquid. And this is explained mathematically in terms of Henry's law. The solubility of a gas in a liquid is given by Henry's law. This law states that the solubility of a gas in a liquid is directly proportional to the pressure of the gas over the solution at a definite temperature. Suppose that m is the mass of the gas dissolved per unit volume of the liquid. It is taken as solubility. That is, m is the mass of the gas dissolved per unit volume of the solvent, and if P is the pressure of the gas in equilibrium with the solution, we have the expression m is directly proportional to pressure, or m is equal to Kp, where K is the proportionality constant. The value of K is different for different gases at a particular temperature. K depends upon the nature of the gas, nature of the solvent, temperature, and pressure. If we use the mole fraction of a gas in a solution as a measure of its solubility, then Henry's law is also stated as the mole fraction of the gas of solution is directly proportional to the partial pressure of the gas. X is the mole fraction. P represents the partial pressure of the gas. That is, X is equal to K dash P, or P is equal to 1 by K dash into X. 1 by K dash is given the formula KH, or it is represented by the unit KH into X, where X represents the mole fraction, P is the partial pressure. So Henry's law is also stated as the partial pressure of a gas in vapor phase is proportional to the mole fraction of the gas in solution, where KH represents the Henry's law constant, P is the partial pressure, and X is the mole fraction. KH depends upon the nature of the gas. Higher the value of KH, lower will be the solubility. So KH when increases, solubility or the mole fraction keeps on decreasing. When we check the statistical data, you find that the KH value for nitrogen and oxygen increases with increase in temperature. So what does that mean? When KH value increases, the solubility decreases. So with increase in temperature, the solubility of nitrogen and oxygen is found to decrease in water. Due to this reason, you find that aquatic animals are living comfortably in cold water compared to that of warm water. According to Henry's law, we have learned that partial pressure is the product of kh and x. When kh value increases, x value should decrease. kh value for different gases in water at particular temperature is tabulated here. On comparison, you find that helium is having a very high value for kh. What does it mean? When kh value increases, the x value should decrease. That is, solubility of helium is much lesser compared to that of hydrogen. Hydrogen is having a lower value compared to that of helium. Come to nitrogen and oxygen. We find that the kh value is found to increase with increase in temperature in both the cases of nitrogen and oxygen. That means at a higher temperature, the amount of kh value increases, which decreases the solubility of these gases in water. Coming to argon, you have a relatively lower value for kh, that means the solubility is appreciable. Now take the case with the gases carbon dioxide, formaldehyde, methane and vinyl chloride. Here you find that the kh values are relatively low, that means the solubility is much high. These gases dissolve better in water. Same as the case with hydrogen chloride and ammonia. They are found to dissolve very much in water because the kh value is very less. Solubility of gas is affected by pressure, and that is learned from Henry's law. Now we shall see the applications of Henry's law. First and the important application is why the aquatic life is able to survive better in cold water. As told earlier, we have seen the case of oxygen. The solubility of oxygen decreases with increase in temperature because there is a change in the kh values with increase in temperature. When kh value increases, the solubility, that is the x value, decreases. The solubility of gas decreases. That is, at a higher temperature, the amount of oxygen dissolved in water decreases, which will affect the survival of these aquatic animals. Coming to the next application, that is, it is found to be useful in making carbonated drinks. When we are passing carbon dioxide under pressure into water, we get a tangy taste for the solution, and that is because low kh value, that is Henry's constant, is very low for carbon dioxide, and so solubility of carbon dioxide increases in water with increase in pressure. Coming to the next point, when we are just checking the case of scuba divers, you find that divers always carry tanks diluted with helium gas. Now, air tanks filled with helium gas is used by them. Why that they are using air tanks? Here you find that scuba divers must cope with high concentration of dissolved gases while breathing air at high pressure underwater. Increased pressure increases the solubility of nitrogen and oxygen in the blood. When divers come towards the surface, there will be pressure variation, which will release the dissolved gases, leading to the formation of bubbles. When nitrogen bubbles out in the blood, it blocks the arteries and causes a medical condition which is painful, and this condition is known as bends. To avoid the bends, scuba divers always carry tanks filled with air diluted with helium. You know, helium is having very high value for KH. That means Henry's constant is very high and solubility of this gas is negligible. It ensures free supply of oxygen to these scuba divers. Coming to the case with mountaineers. At high altitudes, the partial pressure of oxygen is very less than that at the ground level. This leads to low concentration of oxygen in the blood and tissues, which makes the person very weak and he is unable to think clearly. Such a condition is known as anoxia. And to avoid this condition and to get free supply of air, these climbers always carry oxygen cylinders with them. Coming to the next factor, the effect of temperature on solubility of gas in liquids. Solute plus solvent gives solution. Here the solute taken is a gas and it is dissolved in a liquid to form the gaseous solution. We assume that a dynamic equilibrium is created between the solute and the solvent when it forms the solution. The solubility of gases in liquids are usually an exothermic reaction due to which the solubility decreases with increase in temperature. When dissolved, gas molecules are present in the liquid phase and dissolution is also considered as a condensation process where heat is evolved. So, according to Le Chatelier's principle, if the forward reaction is exothermic, the backward reaction will be endothermic. When we increase the temperature of the system itself will try to reduce it in such a way to decrease the temperature. As a result, the backward reaction occurs or dissolution becomes lesser. Due to this reason, you find that when we try to dissolve the gas in a warm solution, the amount of gas that dissolves will decrease.